The moon has fascinated man since time immemorial, and many structures have attempted to emulate its symmetry. Ancient cultures used domes because of their beauty and their innate strength. Since then, the dome has become part of many civilizations, and many of the world's most famous buildings, both religious and otherwise, incorporate domes as an integral part. However, one of their major drawbacks has been difficulty of construction and the enormous cost involved. The Bini Shoal system, named after the inventor Dr. Dante Bini, has overcome these problems. This documentary is on the largest Bini Shoal dome complex in the world, the Spacecity shopping centre at Kalanga near the Queensland capital of Brisbane. Although the layman might think the almost overnight appearance of a Bini Shoal building is a magic-like procedure, it is in fact a very practical and well-tested process. Like all projects, it follows a pattern, and one which in many ways is similar to traditional construction. As in the case of this Kalanga project, the Jennings team works in close association with Bini consultants and other commissioned consultants being involved on feasibility, design, finance, and of course, functionability. The physical job begins with the clearing of the 2.1 hectare site. In the case of the Bini Shoal, foundations are circular in plan and known as ring beams. When the footing excavation is completed, a working slab is poured and formwork fixed in position. This is followed by the placing of foundation steel reinforcement. Provision has been made for the inclusion of an 8-shaped inflatable tube. The recess formed by this tube is the anchorage system of the inflatable formwork. The foundation concrete is then poured, and before it sets, the perimeter ties are placed in position. These will ultimately be used to tie down the outer PVC membrane, which covers the concrete during the inflation process. The ground inside the circular foundations is filled, levelled, and the area consolidated. The main inflatable formwork, known as pneumoform, is put into position, and a test inflation carried out as a lead-up to the inflation process. After this test, the pneumoform is deflated and folded in a set sequence in readiness for the main uplift. Over this folded pneumoform is placed a series of 3 metre by 3 metre PVC sheets, which are overlapped in a herringbone pattern. These help reduce the friction as the large expanse of concrete is lifted. Of course, the concrete has to be reinforced, and this is another of the imaginative procedures involved in a Bini Shoal construction. A series of springs are stretched to required lengths. The springs are laid across the inflatable formwork in a predetermined pattern. The springs are then pulled taut and connected to the outer spring. As each spring is placed, lengths of conventional rod reinforcement are passed through them. The springs have no structural function, however they perform the task of ensuring that the structural steel rods achieve their designed position in the dome, assist in controlling the dome shape and concrete thickness, and restrict the concrete from slumping down. The next step is the concrete pour. This concrete is a special blend which contains plasticizers and retarders to ensure good workability and to extend the setting time for the required period. After the pour, the outer membrane, which has been pre-folded, is then unrolled into position over the wet concrete. The vibrators, which will be used to reconsolidate the concrete of the dome after it has risen, are placed into position around a centre pivot. Then it's go time for the inflation. Now all the final checks are carried out and the pumping station becomes the focal point. Adjacent to the pumping station are standby generators which can be used to continue the lift and ensure stabilisation is maintained in the unlikely event of a power failure. The pumps are started and the air is driven in at pressure no greater than that needed to puff a cigarette, and within seconds the inflation can be seen happening. It is the only power which lifts the concrete into the desired shape and eliminates the tedious and expensive conventional methods which are also so time-consuming. The shell takes about an hour to rise into position. The inflation is best illustrated by the use of our time-lapse cameras. Once the shell is up, the vibrators are started and guided around the external surface of the dome by members of the Jennings Binishell team who keep them the desired distance apart. These vibrators ensure that the concrete is properly recompacted and spread evenly within the inner and outer membranes. The air pressure is maintained inside the dome for between 1 and 3 days, depending upon the diameter of the dome. This is the setting period. The inner and outer membrane are removed for reuse on other projects. The Spacecity project is a fascinating exercise, not only because of its complexity and size, but because so much thought had to go into combining all the domes into one labyrinthian complex. Thus, the provision of accesses and windows was an interesting one. These spaces are started whilst the external treatments are being applied. A vapour barrier is applied over the dome. An insulating foam is the next to be applied on the external surface above the render line. Following this comes a render which is applied from the base of the building to a height of some 3 metres prior to the application of the waterproofing and after the openings for windows and doors have been completed. So, just 3 weeks from the commencement of the project, the first dome was up and ready for the task of fitting out, free from any weather problems, which of course on a normal building's timescale would be impossible. The internal effect in this Binishell complex is magnificent. The high ceilings giving a feeling of relaxation and space so lacking in many modern projects of this size. The vast areas, unimpeded by columns and other obstacles, allow the design team and the client free rein to create exciting shops. The construction from commencement on site to the opening day covers over 6,000 square metres of fully air-conditioned shopping, including a department store, cut price centre and 35 specialty shops. It took just 6 months to complete this imaginative centre. The Spacecity project is an excellent example of how the Jennings expertise can be utilised, from feasibility studies right through to finance and construction, and all built to time and budget. The centre shows just what this revolutionary process can achieve, and that the only limits to its use are the human imagination.